Hello, Year 11. Welcome to our next lesson where we're working on 14K, okay, further symmetry properties and the Pythag identity. Okay, so what we're going to start with complementary relationships. Okay, so we're going to look at how we can find values that are exactly the same, they're equivalent. We're actually finding the same value. So if I look at that second function, if I'm trying to find sine theta, so if I draw my unit circle, I'm only going to deal with my first quadrant just to use this as an example. Okay, so this is my first quadrant. That angle's there is 0, and the one at the top is actually pi over 2. If I have a particular line, okay, I might change the colour. If I have a particular line that works anywhere here, okay, that's given me a particular angle, okay, theta. We can call this P of theta. Okay, what we're going to do is when we deal with sine, we're actually finding the vertical component. Okay, so that's our sine of theta. What we can do is we can use this cos function and find the exact same value. And how we do that is that we actually use pi on 2 minus theta. So we're essentially going pi on 2 and we're subtracting our angle theta. Okay, and what that will give us a new angle. Let's say I call it that, that's our new angle. And what that new angle does is if I break down this different triangle, so rather than using that lower triangle, the one that's in there, I'm actually using the second one, okay, the second one here. And if I think about these sides and that triangle right there, okay, so I've got to draw that separately over there. Okay, so we got that. That's our right angle. Okay. Our hypotenuse is 1. Okay, remember it's a unit circle. This side here is actually our adjacent. Our adjacent is actually 8. Okay, and if this is our hypotenuse, we can actually use the cosine theta, cosine function. Okay, and that cos function, okay, either that or cos of pi over 2 minus theta, they actually find the exact same length. Okay, they're actually finding either that top length or that length there, and they represent the exact same value. Okay, and this is where our complementary relationships come into play. And this is how we generate all the other ones. So these are just the exact same opposite. So if I'm trying to find cos, my horizontal displacement, I could use my sine function in my second triangle. And these last two ones, down here, they work exactly the same except they deal with values in the second quadrant. Okay, so to find the cos function in the second quadrant, it's the same as sine pi on 2 plus theta. Okay, and the second one is cos pi on 2 plus theta, and that equals negative sine theta. Okay, so they find the exact same, they're just dealing with values in the second quadrant. Okay, what we've got is we've got a few examples here. Okay, so let's try and work this out. So if sine theta equals 0.3 and cos alpha, okay, that little alpha symbol equals 0.8, find the values of sine pi on 2 minus alpha. Okay, and how we solve that is remember that the sine pi on 2 minus alpha is actually equal to cos of alpha. Okay, so remember that they represent the exact same value. And we know cos of alpha is actually 0.8. Okay, so that actually equals just 0.8. Okay, so we're finding that identity. So remember that the pi on 2 minus theta equals cos of, or in this case, alpha that we're dealing with that angle. Okay. The cos pi on 2 plus theta, okay, pi on 2 plus theta, going back to that last slide, hopefully everyone's copied down those formulas. When we go pi on 2 plus theta, that actually equals negative sine theta, okay, which becomes negative. We know sine of theta is actually 0.3 from the question, so this just becomes negative 0.3. There we go. And the final one, what we have sine negative theta, okay? So remember when we're dealing with a negative angle, okay, very poorly drawn unit circle, okay, so remember that we're actually going down into the fourth quadrant, okay? So if we're dealing down into the fourth quadrant, what we're finding is that vertical distance, okay, because we're dealing with sine, okay, remember it's sine, we're finding the vertical distance, we're going to get a negative value. So what I can do is I can bring that negative out to the front. So that becomes negative sine of theta. So remember, it doesn't matter what that angle in there is. Oh, if I can draw that angle or that angle. If they're the same angle, you're going to get the same sine function. Just one of them is going to be negative because it's in the fourth quadrant. Okay. So negative sine theta, I bring the negative at the front. We know sine is 0.3, so this becomes negative 0.3. Okay, so we'll take a little bit of practice, but once you get the hang of it, they're reasonably straightforward. Okay, now we're going to deal with the Pythag theory. Okay, so I'm just going to move my head because you can't quite see the last little bit of the unit circle. Okay, so this is our unit circle in the first quadrant. Okay, we're only going to deal with the first quadrant. As you notice, we've been dealing with a lot of right angle triangles. Okay, and we've been dealing a lot of tricks. We can apply the Pythag rule. Okay, so remember Pythag is a squared plus b squared equals c squared. Okay, in this case, c is 1. Okay, so 1 squared is 1. So no, that's 1 squared. Our a can be either the cos or the sine. In this case, I'll do the a. So instead of writing cos, we write cos squared theta. Okay, and we're going to go plus sine squared theta. Just be careful though, guys. When we're squaring trig functions, our squared value is actually written just after the cos, not after the angle. So it's not written as cos theta squared. Okay, that's not correct, because what you're actually doing is just squaring the angle in that case. Okay, we want the whole cos function squared, and that's just some mathematical notation that we have. Okay, so that is in its proper location. What that is equivalent to is, think of it as cos theta close bracket all squared. Okay, that whole thing squared. That's the same thing. It's just a simplified form. Okay, so Pythag theory is very helpful in these cases. Okay, and we can apply it to sine and cos to give us some more information if required. Okay, so I've got a couple of examples. So given that sine is equal to 3/5, okay, so sine of x is 3/5, and the domain. Okay, so remember, we need to look at the domain. Quite a few people happen to be missing what the domain means. Okay, so if we're dealing with pi on 2 to pi, if we deal with our unit circle, okay, up the top we're pi over 2 there, and here we're pi. So we're actually dealing in the second quadrant. Okay, so we're dealing in the second quadrant. Okay, so we need to be very careful with what values we're going to generate. Okay, so I'm trying to find what cos of x is equal to. Okay, so what I'm going to do is I'm going to write the Pythag identity. Okay, so cos squared of x plus sine squared of x equals 1. Okay, so what values do I know? I know sine. I don't know cos. That's what I'm trying to find out. So I go cos squared of x plus sine squared of x. I know sine of x is 3 over 5. So what I can do is 3 over 5 squared equals 1. Okay. What I'm going to do is I'm going to bring that whole fraction over to the right hand side. Okay, so this becomes 1 minus. I'm going to expand the brackets as well. So 3 squared is 9 over 5 squared is 25. And that is equal to cos squared x. Okay. So what I can do, 1 minus 9 on 25. So 1, I could write 1 as 25 over 25. Okay, so remember that. Don't normally write it down, but you need to start thinking of that. So 25 minus 9 will be 16 over 25. Okay, and this is still cos squared of x. Okay, what I'm going to do, I need to find cos of x, not cos squared of x. So what I can do is I can bring that squared to the other side, and that simply becomes square root. Okay, so square root 16 over 25. So remember, when we square root, we get 2 possible answers, plus and minus. Okay, what you find is both the 16 and 25 are their own individual perfect squares, and this will simplify to plus and minus 4 over 5. Okay, but remember our domain. Remember that we're only dealing with the second quadrant. Okay, so if we're dealing with the second quadrant, we need to think about, okay, what values are positive and what values are negative. So which value we're going to use. So this is where we refer to, for me, my cast. Okay, to find out what functions. Okay, in the second quadrant, only sine is positive. So if I know sine is positive, that means cos must therefore be negative. Okay, so even though we have 2 solutions, we know that within that quadrant we're only going to generate 1 value. Okay, so what I'm actually going to do is it's actually the negative that is the correct answer. Okay, and we actually get negative 4 over 5. Okay, and that's our solution with that. So be careful. And that's why they give you the domain, just so they can let you know which is positive and which is negative. Okay, so a lot of these you'll be dealing with just one answer rather than the two. Okay. So what we're going to do with the next one, okay, tan of x, okay, so we know that tan of x is equal to sine of x over cos of x. Okay, so remember that tan is the gradient function. Okay, so this is just simply rise over run. Okay, remember the sine is the rise, the vertical distance, cos is the run. Okay, so now that we have those two values, what do we know? Okay, sine is 3 over 5. Okay, so I'm going to bracket there, and it's divided by cos, which is negative 4 over 5. Okay, what I'm going to do is I'm going to break these up. So negative 3 over 5 divided by negative 4 over 5. Remember, when we divide fractions, we flip the last function, okay, our denominator fraction. So this becomes 3 over 5 times 5 over negative 4. Okay, we simplify. So 3 times 5, 15. 5 times negative 4 is negative 20. Okay, to simplify that function, what we get is we get negative 3 over 4. Just brought the negative to the top, doesn't really matter. Okay, but that's our value for tan of x, negative 3/4. Okay, so that's 14k. Hopefully a few of those examples make a few sense. The Pythag theory is very handy to help us solve a few solutions, and obviously those complementary relationships, that can make it a little bit easier. Okay, so continue working with that. Work with the questions that I've handed out for you, and good luck.